Hi everyone, welcome back to Learn IT with Venkat. Today's video I am going to discuss about how to do subnetting easily, which is the very basic and first task for an administrator in a local area network. Actually, subnetwork or subnet is a logical subdivision of an IP network. The practicing of dividing a network into two or more networks is called as subnetting. You can perform this subnetting on class A, B and C network. In this video, I will give you one easy chart through which you can easily calculate the subnetting. We will see how. Subnetting, so which is used to divide the network into small networks. Here we are using IP version 4 IP address, which is 32 bits in size. This 32 bits, we call it as 4 octets. 1 octet equal to 1 byte, which is equal to 8 bits. For example, if you take this IP address 10.0.0.0, each place which has 8 bits, so 10 is having 8 bits, 0 is represented in 8 bits, so together we have 8 plus 8 plus 8 plus 8, 32 bits. If you take this 8 bits representation, here I am drawing it in the table, that 8 bits representation, here I am going to plot it. So 8 cells we need. One, two, three, 4, 5, 6, 7, 8 cells. Okay. For binary 2 to the power of n, so it starts with 2 to the power of 0 from right to left. So 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5, 6 and 7. You can see it's from 0 to 7, so 8 bits. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 1, 2 is 2, 2 2s are 4, so 4 here. So no need to calculate it. Actually it starts with 1 plus 1 2, 2 plus 2 4, 4 plus 4 8, 8 plus 8 16, then 16 plus 16 32, 32 plus 32 64, 64 plus 64 128. So like this only it will go. Now I am going to add the values. So 128 plus 64 192. So 192 plus 32 is 224, plus 16 is 240, plus 8 248, plus 4 252, and plus 2 254, and plus 1 255. So this is the logic. If you add all the values, you will get maximum 255. So now I am going to plot each octet's positions. So first octet position 1 2 3 4 5 6 7 8. So first 8 bits position, and next the second octet 9 10 11 12 13 14 15 and 16 for second octet, and for third octet 17 18 19 20 21 22 23 and 24, and the last octet fourth octet position, which starts from 25 to 32. So these are all the 32 bits position, which you can easily understand it. 4 octets, so 4 octets position here, and that binary representation and the values added at the top. No need to bygot it, which is very easy for you to understand it. So first I am going to take a class A IP address, which is 10.0.0.0/8, which is a class A. So by default it has network bits 8, which needs 10 subnets here. So this network wants 10 subnets. So 2 to the power of what will give 10? So 2 to the power of 4, which gives 16. So we need 4 bits extra. So need 4 bits for 16 subnets. So here by having 4 bits, we can form 16 subnets, but requirement is only 10. So already we have 8 network bits. Added to that we have to make 4. So total 12. So 8 plus 4, 12 bits. So 10.0.0.0/12 is the IP address for this subnet mask. So once you compute this 12, then you have to look at the chart. 12 is in which acted? Second acted. So straight top 240 in the second acted. You can see first acted full, 12 is in the second acted. So if you look at 12 top 240, so 240 at the second position, which is going to be the subnet mask. Clear? Now we have to compute the network ID, first host ID, which is IP address, and last host IP address or ID, and broadcast ID. So these four parameters we need to compute. So for the first network 10.0.0.0/12, the first host IP address, obviously it is going to be 10.0.0.1. The last host, we have to find out the next network ID. Then only we can find out the last host of that network. So for the 12, look at inside the table, which is 16 in the second row. So the second network starts with second acted 16. How? If you look at the second acted 12 top 16. So that is the second network starting address. How I can do it? Suppose if you want to compute it in binary, no need to compute once you understand this, but suppose if you want to confirm it, you can take that binary conversion also to confirm whether it is correct or not. So 4 bits we borrowed actually. That 4 bits in the second acted, that position is 128, 64, 32 and 16. Hope you understand. These 4 bits only we borrowed from the host portion actually for 10 subnets. If all zeros, then 0 in the second actor. That is what here we platted. And the second is going to be 001, which is 16 now. That is what here I platted. Hope you understand now. Next is going to be 0010, so which is 32. So next network is going to be 32.0.0/12. So like that only it will go. If you want to compute again, no need to compute binary, easily you can do it. If it starts with 16, then all the things will plus of 16 only. So 32 plus 16 is 48. You can see it in binary also, 0011. So obviously next is going to be 48. So like that it will go all 4 ones. When if it is all 4 ones, 128, 64, 32 plus 16, we already knowing it, it is 640, which we have computed for subnet mask. Clear? So it will go up to 10.240 0.0/12. Here you can confirm it. As I said before, if you add 16 here, you can try, but here you will get 256, which is not possible here. So 255 is the maximum. So this address is going to be the final. So for the first network, last host is going to be 10.15 because 16 is the next network. So 15.255.254. Then broadcast is going to be 10.15.255.255. And for the next 10.16.0.1 is the first host IP address. Then 10.32 is the next network. So 31 is the last host of this network. 255.254 is the last host and 255.255 is the broadcast address. So like that it will go up to the last. So 10.240.0.1 is the starting IP. 10 point next is actually 255 because 256 is not there. So full 255, 255, 254 and the broadcast is 255, 255, 255. Hope you understand. Clear? So here 8 network bits for 10 subnets we borrow 2 to the power of 4, 16. So 4 bits additionally we need. So already 8 we have. 4 bits actually we borrowed from host. So that should be added along with the 8 bits. So it gives 12. Once you get this number, you have to look at the table. 12 is in which acted. To the top is going to be your subnet mask. So which is going to be here and that table is going to be the 16. is your next network address. So plus 16 is going to add. From this chart you can take everything. So now we will see class B IP address, second one. So second 172.16.0.0/16 is the class B default network bits, which needs here 30 subnets. So for getting 30 subnets, look at the chart. 2 to the power of what we will get 30 means 2 to the power of 5 we will get 32. So here 5 bits extra needed. We have to borrow it from the host person. So needs to be borrowed from the host. Already here we have 16 bits plus 5 here. So total we will get 21. So 172.16.0.0/21 is the network bits now. The subnet mask, just look at the chart, where is the 21, in which acted it lies. So if you look at here, 21 is in the third acted, and look at the top 248. So third acted means first two acted full, so 255 and here 248.0. so 248 is the maximum network person we can go. So network ID, first host ID, last host ID and broadcast ID we have to calculate. So first network is obviously it is going to be the given address. So 172.16.0.0/21 is the network address. So first host IP address is 0.1. For computing the last host ID, we have to compute the next network address. So look at the chart. 21 straight in the chart table, it is 8 in the third acted. So 172.16, 8 in the third acted, 0.0. As I told before, plus 8 plus 8. Once it starts with the number, it is going to add off that number only. So 8 plus 8, 16 plus 8. So 172.16 point here 24.0 plus 8 here. So 172.16.32.0. So it will extend up to what it will extend? 172.16 point up to what? So you can look at the subnet mask here. So 248 is the limit. You can directly take it from there. So this is the last network ID. You can check with the binaries also if you want to confirm it. So 5 bits we borrowed. So 128, 64, 32, 16, 8. So these are all the 5 bits we borrowed from the third acted. So 0, 0, 0, 0, all zeros, which gives 0 here. That is what the first network third acted. Then 0, 0, 0, 1. So which is 8. So that is what here we got 8. And then 0, 0, 0, 0, sorry 1, 0, we will get 16. So up to what it will go? All ones. So all 5 bits ones means if you add all these things, you will get 248. That is in the chart. That is what here. If you add 8 again here, you will get 256, which is wrong. So it will not be there. So this IP is going to be the final network IP. So last host ID for the first network 172.16 point. Next network is starts with 8. So here 7.254. 172.16.7.255. So next it starts with 8. So it should end with 7 dot. Here 172.16.8.1. So next it starts with 16 here. So it is 15.254 and 15.255 is the broadcast IP and so on. When you go for the last network 172.16.248.1 and last host IP address 172.16. Now 255.254 and the broadcast is 172.16.255.255 is the broadcast IP. So this is how we have to compute. I hope now you could understand easily. Very simple. The same procedure here we will try it out with class C also. Okay, so the same chart here I have taken. Now we will try with class C. So 192, 168 point, for example 1.0 if I am taking, and 24 is the class C default network bits here, which needs, for example 50 subnets we will take. 50 we need here. So look at the chart again. 2 to the power of 6 is 64. So 2 to the power of 6 equal to 64. So maximum 64 subnets we can go if you have 6 extra bits. So which has to be borrowed from the host bits. Already we have 24. So 24 plus 6 bits needed. So plus 6. So network bits now become 30. So 192.168.1.0 30. Look at the subnet mask now. Where that 30 actually? 30 is in the 4th octet and subnet mask is 252. Okay. 4th octet 252. So 3 octets full. So 255, 255, 255. 3 octets full. And the last 4th octet is 252. Because 30 lies in the 4th octet. Network ID, first host ID, last host ID, and broadcast ID we have to compute. So this chart will be very useful to do all these things. If you have this chart, you will do the subnetting within 1 or 2 minutes very easily. So network starts with 192.168.1.0 slash now 30. The first host obviously it is going to be 1.1. We know that. So 192.168.1.1. For computing last host, we need the next network. Look at the chart 30. Inside the table, we have 4 in the 4th octet. So 192.168, 1.4th octet is 4 slash 30. So for last host IP address 192.168, 1.2 here, and broadcast ID is going to be 192.168.1.3 because 4 is the next network. 192.168 1.4 plus 4 8. So first host IP for the second network, which is going to be 5. 192.168, sorry, here also 68, here also 68. 168.1.6 and 7 is the broadcast IP. So the previous IP is going to be the broadcast of the previous network. Up to what it will go? So 252 is the reference here. So 168.1.252 is the, you can look at the subnet mask. If you want to confirm it, just put 4 is the changes, right? So 4 you add it here. If you add 4, 256, which is not possible. So 252 is the final one. So 192.168 1.253 here, and last host 192.168 1.254 and 192.168 1.255 is the broadcast IP. So in each network here we are having only 2 IPs because we have taken 50 subnets here. If you have this chart, which will be very easy, the same chart we will use it for VLSM also. Okay, that I will put it in the next video. Hope you understand. If you like this video, share with your friends, subscribe the channel. Bye bye.